Hi everyone, this is Arun Reddy here. Welcome to my YouTube channel Arun Reddy Tech for You. In this video, we are going to learn about DBMS architecture. So friends, if you are new to my video and if you want to learn DBMS, you can go through my channel playlist. In playlist, you can find DBMS. Okay, so there is a DBMS folder where videos are in English. Okay, and you can also find another folder DBMS in Telugu. If you want to learn videos in Telugu, you can also have a Telugu videos. Okay, and if you don't want to miss my video, please subscribe my channel and don't forget to like and share my videos. So let us go to our topic. Okay, so now today we are going to deal with the topic DBMS architecture. Okay, so not only DBMS architecture, we are going to learn about types of DBMS architecture, three schema architecture of DBMS, data independency. So first let us start with DBMS architecture. Okay, so what is DBMS architecture? DBMS architecture refer to overall design. So what is this saying? Overall design and organization of database management system. So what it is saying? It is a overall design and organization, means how it will work. Okay, so it includes hardware, software, data and personal components. So what it includes? It includes hardware, software, data and personal components. And what it will do, it will define the way data is stored, processed and retrieved from the database. So what we are saying, it is overall design. It includes hardware, software, data and personal personal components, and it will also help us to understand how data will be stored in database, processed in database and retrieved from the database, right? So these DBMS architecture actually divided into three categories. So what are there? One tier architecture, second one is a two tier architecture, third one is a three tier architecture. Okay, so one tier architecture will also called as single tier architecture. So let us go one by one. So first let us start with the single tier architecture, that is one tier architecture. So one tier architecture in DBMS is the simplest architecture. It's very simple. Okay, simplest architecture of database in which the client, server and database all resides in same machine. So what you are saying, this is a simple one tier architecture. In this only we have a client, in this only in the we have a database. For example, I have a PC. So in the PC only I have a database, and in PC only I have a SQL query. Okay, SQL application, or I can say DBMS tool. Okay, so to operate the database. So what we are saying, what you understood, client and server resides in only say one machine. Okay, so in the one machine, client and server resides in one machine. Best example is your PC computer. Okay, so where you can see the data in the same computer and where you store the data is also in the same computer. Then what is two tier then? Two tier where client will be somewhere and server will be somewhere. See, two tier. One tier is client, two tier is the database. See, you can see here. Two tier architecture is DBMS. In DBMS is database architecture where presentation layer runs on client. Of course, client will have a presentation layer like a PC, mobile, tablet. They are examples. For example, you have a system. So your system is now a client. Okay, and in that client you will have a presentation layer, right? And data is stored in where? Server. Where data is stored? Here we are saying database. So called second tier. So now database is called as second tier, right? So two tier architecture provides added security to DBMS as it's not exposed to the end user directly. So what you are saying here, database is somewhere and client is somewhere. Okay, and you are not directly exposed to the database, means database is not exposed directly to the client. That means client cannot see everything. For example, in one tier, he knows where the data is stored, where the data is located, what is the location of the database, and how it is stored, what is the space of the database. But here, what happened, two tier, it will abstract. Okay, it will provide data abstraction, so that client will see only data which he want. Okay, he cannot what you will say, get the confidential data or the unnecessary data. Right, it will show only required data, and they use API application. What application? Application interface. Okay, so API is nothing but a application interface. Okay, so now what we are saying, two tier. Then what is three tier? Three tier, see, again there is another one between client and server. So in one tier, client and server is one system. In two tier, client will be separate, servers will be separate. In three tier, client will be separate, server will be database will be separate, and application layer is also separate. Okay, so now DBMS will use this application layer, right? So 3-tier architecture in DBMS is most popular client server architecture in DBMS, in which development and maintenance of functional process, logics, data accessing, data storing, user interface is done independently by the separate module. So what you are saying, storing, retrieving, data accessing, all will be done by a user interface. Okay, so which one? This one. So separate module we have, this will deal now. Now database doesn't need to worry about the data. The application layer will deal with this clients, and it will retrieve, store the data from the database, and it will show the client. Now another layer came into existence. That's why it is called 3-tier: 1-tier, 2-tier, and 3-tier. Okay, so in 3-tier architecture contains presentation layer, that means client, application layer, the middle server, okay, and database, that is third server. Okay, so second server, sorry. So these are the 3 layers. Okay, so that's why it is called 3-tier. Okay, so then what is the use of this 3-tier? Let us move to the next. Then there you will understand easily what is this 3-tier architecture uses. Okay, so mainly 3 schema architecture of DBMS will help you to understand what are these 3 tiers: 1-tier, 2-tier, and 3-tier. Okay, so generally the word says 3 schema architecture of DBMS. That means it has 3 schema. Schema means again designs. Okay, 3 different schemas. Okay, so here schema means design, or we can also say as view levels. Okay, so view level is also considered as a schema here. Okay, actual schema definition is nothing but a design. Okay, so what is this 3 schema architecture of DBMS means? 3 schema architecture describes how data is represented or viewed by the user in database. See, we will see data in different level. We means the user. For example, I am a user. Okay, I will, when I open a Gmail, I will see a Gmail in the form of some vertical layers will be there. Okay, so each record will be there in the form of mail, right? So now my view is different, but how it store is different. So what this 3 schema architecture is doing, it is helping the database to show in a different way. Okay, so now user will see in a different way, but it will store in the different way, right? So why we have to show in a different way, let me explain you. Okay, so it is also called, this architecture is also known as 3-level architecture. So 3 schema architecture, 3-level architecture, logical architecture. See, different names we have. So somebody will say 3-level architecture, somebody will say logical architecture, somebody will also say ANSYS sparse architecture. So it has different names, right? Okay, let me explain you one diagrammatically so you can understand easily. Okay, so this architecture contains 3 levels: external level, conceptual level, and internal level. What are these? External level, conceptual level, and internal level. So let me show you a diagram. So this diagram you can see. So top one is the external level, where when a user can see. Okay, second one is conceptual level. Okay, in this conceptual level, database designer will be involved. Okay, so it will help us to design the data, how our data should be stored. For example, if we want to store in the form of table, so what are the columns should have, what are the data types of a column should have, attributes should have, all these were again described in the conceptual level. Internal levels contains storage of data, how much space it should contains, whether you want to continue in the same storage, or you want to expand, or you want to decrease the size of a data storage. Okay, or you want to store data in the form of files, or how. So all these will be again described in the internal schema, right? So there is a database. On the database we have a 3 levels, 3 different levels. Okay, so external level, conceptual level, and internal level. We will also call it as external schema, conceptual schema, and internal schema. It will also have another name. It has view level. External level is also called as view level, conceptual level is also called as logical level, and internal level is also called as physical level. So one by one we will go. Okay, so first let us start with the external level. So what is external level means? External or view level, the highest level of database abstraction. What it is? Highest level. That means data abstraction means hiding the data. So here the data will not be shown that database, what it will do, it will not show everything. So in the view level, what happened, that not database, the DBMS. Okay, so what it will do, it will show different data in different form. For example, if I open a Hotstar, now I didn't what do you say, I didn't have any login, what do you say, a premium, I didn't paid any premium in the Hotstar. So what the Hotstar will do, they will allow you to see the serials, okay, or a web series. If you pay, then they will allow some premiums. Okay, for example, there are some movies you can see on your login, same login. If you pay more VVIP, then you can see more movies in the Hotstar, right? Same way Amazon is also there. So if every person will have a different view. For example, there is a bank account, you have a bank account. Now bank employee will have a different view, you will have a different view. You can see only your summary, you can see your account balance, you can see your transactions, right? You can see your loan account, but you cannot see other people loan account, right? So other people data, right? So but employee, a bank employee will have a different view level. Okay, for example, you forgot your password or you want to change your settings, password settings, you went to the employee, he will reset again. Now you will get a OTP, and with the help of OTP you are trying to change your password. Now the same access you will not have, right? Same view level you will not have. Okay, you cannot see all these things, right? You can see only your internet banking. Same way, for example, there is a college will have a different user ID, and student will have a different user ID. There is a, let us assume there is a university will have a different user views, and student will have a different user. For example, student will know his attendance, student will know his roll number, student will know how much fees he paid and how much he has to pay. But college will have all the student details, fees details, all student details, all marks, how much they are entering. Suppose they want to modify also, they can do it, college database or a university database, right? Now same thing, if a student will have, what happens, they will misuse, right? So now what data abstraction is doing, it will providing security. Okay, so every different every user will have a different view. Okay, so that's called external or view level. Okay, so actual view of data that is relevant to a particular user. See, based on the user they will show the data, they will not show everything, right? So this level provides different view of same data for specific user or group of user. So what we are saying, view user 1 will have a different view, user 2 will have a different view, user 3 will have a different view based on their logins. Okay, for example, if I want, I have opened a table in the from the database, I can see employee name, employee number, employee name, date of joining, department, and their details. For example, there is employee number 101, employee name some Arjun, Ravi, and date of joining and department. Now I can read, I cannot change. See, my view level is only I can read, right? So like that, so separate, every person will have a different view level, right? Okay, now for example, student login, what they will have, student login will have a user ID, password, he can see the student his details, okay, his notifications, his payment links. Suppose if you want to pay the link payment, he will have a payment link. College, they will have a student attendance, marks entry, fees, payment details, right? So different people have a different view, right? So here this is called view level. So now what is the conceptual level means? Conceptual level is seen by the database designer. See, conceptual level, what it contains? It contains the structure of the data, how data should be stored. Okay, so it is also called logical level. See, this level act as a middle layer between physical layer and, see, internal schema and external schema. Okay, internal level and external level, middle layer. Okay, so middle layer, this is a middle layer. It explains what data to be stored in database. So what data should be stored. For example, if I have given a table, okay, which contains student name, student roll number, student names, his marks, okay, or his mobile number. Now he can enter the only that data. So it will decide what data should enter. Okay, what data to store, right? This schema hides information about physical storage structure and focus on describing data types, entities, relationship. So what it will do, it will it will say it will hide the details of database. So see, it doesn't have any details where it is located, where the data is located, how much the size of a database is, how they are located. All these details will not be there in the conceptual level. It has only logical level. Logical level means, for example, see, in view level, what I said, I can see employee name, employee number, date of joining, department. I cannot see the data type. See, structure of the data. Employee number is number. I cannot see whether it's a number or not. Okay, employee name is in the varchar. I cannot see. If suppose date of joining is a date department is in the varchar, or employee number is in integer. So I cannot see all these details, right? Who? The user. Okay, so user can see only fields and data. We cannot see the data structure. Okay, so data types are again described in the conceptual level. And entities relationship, for example, one table is connected to another table, how they should connected. Okay, how the attributes should be connected. All these are described in the conceptual level, or it is also called as logical level. Then what is physical level or internal means? This is the lowest level. Okay, so lowest level of data abstraction means maximum everything will be opened. Okay, in this level DBA will act. Okay, so in the second level, what it is, conceptual level, database designer will act. In the third, internal and physical level, DBA will act. Now what he will do, he can see in the internal schema, we can directly access a database. See, so what we can see what data we are storing, where we are storing, which location it is stored, what is the size of data, what type of index we are using. Okay, how they are stored. All these are again shown in the internal schema. So internal schema has a direct access, so no data abstraction. So that's why low level data abstraction. Okay, everything is exposed. Okay, so it describes how the data is actually stored in the database, provides method of accessing data from the database. It allows use to physical representation. So it also shows physical representation where the data is stored. Okay, so this level describes how data is actually stored in the storage device. This level is also responsible for allocating space to the database. So internal schema is main responsible where the data should store. It will decide. Okay, so which location they have to store, how much they have to provide the space. Okay, so that's the specialty of internal or physical level data storage, right? So this is what your 3-level architecture. Then what is the use of this 3 schema architecture means? Data independency. What do you mean by data independency means? See, I will change something in the design. For example, I want to store the database from one place to another place. Now user should not know this. For example, I want to add some more columns to the table. Now user should not know this. So to hide the data modifications, what we use? Data independency. Data independency is a concept. What it is? The ability to modify the schema definition of DBMS at one level without affecting the schema definition of next higher level is called as data independency. What we are saying, I will show you in the diagrammatically. Okay, so generally there are 2 types of data independency: logical data independency, physical data independency. So what do you mean by that means? For example, any changes in the conceptual level means, for example, table, I want to add a column, modify a column. Now that will not be known to the user. User will not know these things. Okay, so any changes in the internal schema. Okay, for example, I want to change hard disk, magnetic disk. Okay, from C disk to D disk I want to change. So these changes also will not be known to the user. Okay, so this is called physically. And even conceptual schema, database designer also will not know. Any changes done in the internal schema will not known by the conceptual schema. Any changes done in the conceptual schema will not known to the user. Okay, that's called logical independence. Okay, so any changes done in internal schema will not known to the conceptual and end user, then it is called as physical data independency. Any changes done in the conceptual schema will not known to the user is called as logical independence, logical data independence. So once we will go in depth what is logical independency and logical data independency and physical data independency. Okay, so logical data independency refers to the characteristics of being to change conceptual level without having any changes to the external schema. So what you are saying, user will not know if we change anything in the design. For example, I will add, modify, delete a attribute. Attribute means a column, okay, or an entity or a relation, then also user will not know. Okay, suppose I will merge two records, so I will merge two records, then also user will not understand. That means it will, the changes will not represent, changes will not be shown on the view level. Okay, or breaking a record, suppose I want to break a record, that one also a user will not know that one. Okay, right. So what is physical data independency means? Physical data independency means defined as capacity to change in internal schema without having changed to the conceptual schema. So any changes if I done in the database will not known to the conceptual. For example, I will use new storage. Okay, so I will remove the hard disk and I will use another hard disk, or else I will modify the file organization techniques, means how sequence, we have an index sequence, different methods, right? Or else any change in the index, there are different types of index will be there in the hard disk, right? Sorry, database. So if I change also, that will not be known by the to the data designer or in the conceptual schema. Okay, for example, changing the database from C disk to D disk. So I will change from the here to another new disk also. The changes will not shown in the conceptual level or end user level. So these people, the user cannot understand, or even the database design will also designer will also know, don't know whenever we have changes done in the database. So any change done in the database will not known by the conceptual schema or end user. Okay, so that's called physical data independency. Once again I will show you, I will just make a note of what is this logical data independence and physical data independency. Okay, so any changes done in the database will not known by the higher level conceptual and end user is called physical data independency. Means changing of the location of data, or adding a new hard disk, change increasing the sign, decreasing the size. Okay, so adding what do you say, index, or changing the file, what do you say, file organization methods will also affect the conceptual or end user. Okay, logical data independence means adding a new column, deleting a new column, changing the data types, changing the table relations, or merging the records, what is it, dividing the records, breaking the records will not affect the user view. User will see the same data. Okay, so any changes done will not shown in the user view. Okay, so that's a logical independency, right? Okay, so this is what your three schema architecture or database architecture. In that we have a one tier, two tier, three tier, and three schema architecture. In the three schema architecture, we have a external level, view level, and internal level. Okay, so and in that again we have a logical data independency and physical data independence. So main concept of three level architecture, the what is the need means the logical data independence and physical data independence. Okay, so friends, if you like this video, please do subscribe, share, and don't forget to like the video. Thank you.